everyone. Welcome to the episode 13 of our podcast. So, as usual, Sanjiv is joining me. So, in the last episode, we spoke about digital modernization and then looked at how the modernization working in enterprises and what are the steps that you have to take on modernization. And today we thought of slightly change the topic, but a very important topic for architects. We thought of speak about first principle thinking. So I think Sanjiva, first principle thinking, I learned it from you and Paul Fremantle, our founding CTO. So for me, like it's more about a kind of a nice way of finding solutions for the problems. I think there are two ways of finding solution: reasoning by analogy versus reasoning by first principle. I think reasoning by analogy is very popular, that people go with assumptions and then look what other people think and then look at the past experience and just come to conclusions and then building solutions, right? So first principle thinking and then finding solutions using first principles, going against that. So I think it's better you explain it from your experience as well as how you think about first principles.
Yeah, thank you. So, first principles thinking for me is sort of a way to think about problems without the baggage of the past, in some sense. There was that I remember Intel Capital was one of our first was the first not one was the first institutional investor in WSO2, and there was a line from the founder of Intel. It said something about, I can't remember the exact wording, but like, don't be encumbered by the past, go and do something wonderful. Right. So basically, what happens to people is when you become experienced, when you've seen patterns, when you've read books, when you studied this and the other, is you're like, okay, these are the constraints of the space. And you can't, those are the boundaries. Whereas if you really think deeply, often those are not the boundaries, those are fictitious boundaries we've drawn for ourselves. So the first problem of first principles, first aspect of thinking in a first principles way is understand what are your goals, what are the problems you're trying to solve. And if you don't have clarity on that, you might as well forget it, because you're not going to do something, right? So often we in WS2 Asanka, you know very well, when we have intense debates about some things, sometimes you step back and ask, what is the problem you're debating? What is the problem you're trying to solve? And often you can't remember what the hell the problem was, right? Because you've kind of gone off on some tangent and you're talking about something else. So when you don't have clarity on the problem you're trying to solve, you won't even know whether you've solved it, and you will often solve something else. So you can't have thinking from the bottom up, starting. And my way of explaining it was not first principles thinking. This is a newish term. For me, it was always clean whiteboard thinking. Erase the whiteboard, erase whatever you've done before, and start again, right? And start again from questioning assumptions, questioning mechanisms, questioning when people say, well, that doesn't work, or that doesn't scale, or whatever. You say, well, I mean, sometimes you got to be foolish to know that something doesn't work and still do it, and then you break it, right? That kind of approach is what we always try to focus on, saying that you start off by asking, what is the problem you're trying to solve? Why are we trying to solve that problem? Because if you're not solving the problem that should be solved, again, you're wasting time, right? And the other thing which comes hand in hand with first principles thinking is this concept of not conflating problems. When you try to solve a complex problem, it's not one-dimensional, it's multidimensional. There are many different characteristics, many different aspects that have to be dealt with. But if you try to solve all of them at once, you just can't do it. Basically, it becomes too intractable. And you get this behemoth projects, institutions that try to solve these things and nothing ever comes out. All these government systems, I'm very passionate about building public sector software in Sri Lanka. So a lot of government systems, not only in Sri Lanka, all over the world, fail because you fail to do this approach. You just go and say, well, here's a big problem. Here's a spec for the solution for the problem. Now go implement it. Now, no human being, no system is capable of writing a spec for a solution to a problem that is ill-defined. So then as a result, you get a system that just doesn't work. So first part of thinking cleanly is break the problem down, understand the problem, question the problem. Why the hell are we solving this? Does it matter? This is the problem we should solve, right? And then dig in deeper.
Yeah, I think it's a really good overview about what's first principle thinking, and I think this reminds me the kids who's using Legos, right? You can take the exact manual and then build something and be happy with that. But a smarter kid can just break all the Legos into the atomic units and then start building the exact dream
What
he
you want?
has in
Yes.
his or he or she has in their mind, right? And
Yeah.
then get the output that they want. So I think that's pretty cool. So I think for the listeners benefit as well as my own benefit also, I thought of like digging deep into each and every aspect that you highlighted. I think the first thing you mentioned about the root cause analysis, or like focus on the root cause, not the symptoms, right? As an example, like if you take leaking in the roof, you can patch the ceiling without getting into the roof and fix the problem, right? So if you can like a little bit elaborate on that, Sanjeev, I think that will be more beneficial for the
And I just want
uh,
to make a comment on
audience.
Lego and then come to the topic. When my kids were growing up, my son is now just turned 29 yesterday, 2 days ago. So when my kids were growing up, there were no packaged Lego. You buy a set of Lego pieces and you do whatever you want.
Yeah,
Then Lego realized, damn, people are reusing this. So commercial mindset appeared and said, well, I'll give you a packaged solution that you can only do it once. And you make this massively complicated Lego thing, and then I have a bunch of those at home now. I don't know what to do with them because they just gather dust, right?
yeah,
So it was a great commercial solution, but actually went away from the fundamental principle of what Lego is, which is a orthogonal set of building blocks with which you can solve any problem, right?
yeah.
So this is why, in computer science, what is computer science as a discipline? It is not really a science. It is a methodology.
Mm,
It's a methodology. Well, there are two parts to computer science in my view. One is it's a methodology to solve problems. The other one is it is a teaching on how to encode complex problems into a stupid, simple little set of instructions, one way or the other, right? Whatever language, whatever tools you want to use, but something really, really dumb. But you take some complicated problem like catching a rocket, landing, right? There's a lot of mathematics, a lot of physics, a lot of calculations there. Eventually, you're
yeah.
programming a computer to make that work, right? But that programming is really, really dumb at some down at the lowest level. So anyway, so coming to the coming to this topic, uh, uh, sorry, now I forgot what I was going to
Yeah,
answer.
no, we
I
were
went off on a
discussing about the
tangent.
root cause analysis, like how
Yes,
you can
yes.
kind of get into the root of the
Yes,
problem.
yes, yeah. Thank you. I think that is the most important thing, because if you don't do that, you're going to solve the wrong problem, right? So how do you get there? Saying what is the problem you're trying to solve? That's for me the most important question you have to ask yourself and ask your colleagues and ask your team and ask any conversation. Why are we here? What are we here to discuss? What is the problem? And if people can't articulate that, then you got to work on it, right? So I've given a bunch of talks about entrepreneurship and all this stuff. To me, this is, and there are these university programs, there are degrees now in entrepreneurship. I'm sorry, but for me, this is all bogus. Entrepreneurship basically means, look, you see problems in the world. Maybe it is that you go around, you see traffic. Maybe it is you see pollution. Maybe it is whatever the problem in the world that you want to pay attention to. And there are three choices for us as human beings. One is we can ignore it. That's usually what happens, right? After a little bit of time, first day you notice it, second day you might notice it, third day, like whatever, it's just part of the deal, and you ignore it. The second option is you complain about it, say, oh gosh, look at that. Nobody's fixing this. Sort of terrible place. These problems exist. The third option is somebody says, well, that's interesting. That's a problem. That means it needs a solution. That's an opportunity. Now go figure out how do you solve that problem, right? So come to then to solve that problem, you got to really understand the problem. It's like what you said about water is falling down from the roof. It could be that there is a ceiling leak in the roof, It could be that there is something else. For example, I have had this situation. I live in Sri Lanka, so we have tropical. In my ceiling, we are very tropical, so we get animals in the ceiling, right? It's impossible. You cannot stop it. I've done every possible thing to stop it, but they're animals. Sometimes they take a leak on your roof, on your ceiling, right? And then there's some kind of liquid on the ground. Then and it might be a rainy day, right? So you got to deep to understand what is the symptom doesn't necessarily suggest the problem. So you have to ask questions, and you have to just keep digging in one step behind. I remember when going back to my kids, right? When they were small, one, as an adult, an annoying thing was always asking why. You give an explanation, and then you ask, well, why is the answer the case? Then you keep asking that, and after a while, as an adult, you're like, okay, that's it. That's just the way it is, right? This is the axiomatic. In mathematics, that's the axioms, right? When you get down to the axioms, you can't ask why. You kind of take it for this is the axiom that you start on, and then you build a huge castle on top of those set of axioms. But if you don't ask the whys to get down to the correct axioms, you're building a castle on garbage axioms, which don't work for real. And this is where people fail, because they don't ask why enough times. Well, because my boss said so. Because I have a requirements document. Asanka, as you know, we don't write requirements documents in WSO2. We just don't. And now I'm pushing more and more saying don't write plans. It's completely useless. Just go solve the problem. Take some time to solve the problem. Fine. When it's solved, it's solved. Until it's solved, it's not solved. We keep working at it. Because you can't write it down. You can't say, here's the problem to solve. Don't think about it. Just solve this problem.
Yeah, I think now that once you kind of get into the root, then the next thing or the supportive thing for that is basically the reality-based thinking, right? Because accepting the reality, not like what you wish to be. As an example, like even when you want to use GPS, if you don't give the exact location where you are now, it will not navigate to the correct place, right? Even we spoke about modernization in the previous episode. Even to do a modernization, we have to understand where we are now and then kind of build a solution from that point onwards.
Yeah, I think that's a very important point, kind of diagnosing, like, where you are and where you're trying to go, right? The first part is about where you're trying to go. But then if you don't know where you are, you'll again build something that won't get you from here to there, right? Because the goal is to go from here to there, whatever that problem that you're trying to solve is. Uh, and having clarity on what is the current status, what do we believe in, what are the challenges, what are the opportunities. Those are very important things to really dig deep and understand what is the current state of the world, and how do you kind of extrapolate from here to there. And again, you have I wrote a blog a long time ago called something along the lines of personal vision, more than like 10 years ago. I can't remember, whatever, some years ago. Why it's important that everybody should have personal vision, and what is vision. So my explanation for vision was you close your eyes, you imagine a world that is unshackled from the world as it is today. I'm going to use a sensitive term, unburdened by what it has been. Uh, you kind of, I mean, okay, that's a bit of became a joke, but there is some truth to that, which is like, don't hold on to what has been. So that's what vision means. Vision means thinking without the constraints of the current universe, because maybe you're not well, maybe you're not wealthy, or maybe you're not knowledgeable. So how can you imagine yourself being somewhere else, right? But you got to unshackle that and say, okay, that's where I want to get to. Then you have some kind of set of milestones. So same thing about how you think about this, the diagnosis, which is I have to understand where I am so that I can have a set of milestones that drive me in the direction of where I'm trying to go to.
Yeah, I think one reason why people are not identifying that starting point, because people are reluctant to tell the truth sometimes, so they don't want to accept that we don't know something, so kind of trying to put sugar coating around things, kind of making them failure there. And I think you made a really important point about the vision. And one thing that even I figured out, because this is my seventh job. I worked for many other places before. Like when the
Maybe that's
individual vision doesn't yes, when the individual vision doesn't map with the organization vision, then the passion doesn't come out, right?
yeah.
And then it becomes a job. It's not like coming within each individual aspect. So I think identifying those two and then kind of have an alignment. There can be some misalignment always, but like 80% alignment with 20% disalignment might be really helpful.
Yeah,
Yeah,
I have had this conversation with multiple people saying, should you work in WC2? If you're an employee in WC2, should you stay in WC2? So my explanation is based on linear algebra. It's orthogonal. So if the way the company wants to take you is in this direction, right? And then you want to go in the opposite direction, then you're not helping the company, nor are you helping yourself. So basically, if the direction you want to go in and the company's direction, anything more than 90 degrees, you should leave. It's bad for you, bad
yeah,
for the company. You
yeah,
guys are going backwards, basically. Both you and the company, your employer are going backwards. If it is if it's 0 degrees, it's perfect. But it's not 0 degrees for me even, right? I'm the founder of WSU. And it's not 0 degrees. That's stuff I want to do. That's not what WSU wants to do. So
yeah,
it's not zero, but it's certainly, it should be as low as possible so that when you pull together, you get the strength of something close to the two horses pulling in the same direction. Yeah, we use this analogy inside WSO regularly, right? We have 780 people or whatever. We either have a 780 horsepower engine, or we could have a 0 horsepower engine, or we could have everything in between. Of course, we don't have a 780 horsepower engine. Obviously, we don't have a 0 horsepower engine because we are doing various things and we are making great progress. But we are somewhere in between those two numbers. The more you can get towards 780, which is align everybody in one direction, the more you can actually pull together in depth, right? So it is exactly what you said about getting people come to an agreement on like what are we doing, why are we doing it, how do we do it, is really important. Otherwise, you just waste all this time debating and talking, and you have this discussion, you agree on something, and then you get sort of passive aggressive behavior in the enterprise where you agree on this high level thing, but underneath everybody disagrees,
yeah,
right? And then you don't go anywhere.
yeah. So I think when you explain about clean whiteboard thinking of as principles, another thing that you mention is build from the ground up with logic. Like as an example, like when you build a building, you should have a solid foundation, right? Not the penthouse that you are building on top of it. If you start with that, then it will collapse the building. So I think having that ground up approach to build the solution from ground up is a key part of first principle thinking.
Yeah, yeah, absolutely. I think the approach of saying um, don't a don't start with the end state, right? You got to start from the bottom, your foundational place where you start, and then as time goes along, you want to push things down so you don't see it. Like when you are doing the wiring of the 13th floor of the building, since it's our 13th episode, I think, when you're doing the wiring of the 13th floor of the building, you don't worry about the foundation, right? That is invisible to you. And that's where we came to this concept of platformless, right? Which is you think about things up to a point, and then it's not your problem. You shift it down, basically. And but that down part, whoever's working on the foundation, if whether it is an enterprise architecture or it is a overall architecture of a new application you're building, or the architecture of how you do integrations, or whatever the component of that business problem that you're trying to solve, if the foundational sort of skeleton of that is wrong, it's never going to work.
Yeah, yeah. I think that's another misconcept about first principles. Like people think it's concrete, but I think again the iterative process that we talk about, like how you kind of redefine ideas through feedback loops, is pretty important, right? I think it's like just artists who take a kind of a metal or a stone and then keep on working iteratively till they get the end state. So I think that's another important thing that we need to follow when we are working on first principles.
Yeah, and I think we have written. I think you've written some blogs about this concept of iterative architecture,
Yeah.
not just sort of development, right? So this concept of Scrum and development by milestones is well understood, but often people try to design a system for the end state, and you may never get to the end state. And you don't need to design Facebook to handle 2 billion users when you start. You redesign it, right? You keep the right experience layer consistent, but you can redesign the guts of it. So it's very important that iterative way of thinking about the problem, as you said, is critically important, which is otherwise you'll never finish it either. Right. Well, let me rephrase that. You'll never deliver it because you never finish. In a software system, it never finishes. Microsoft Word is not done. It's been around for 30 years. It's not done, right? Google Meet, we are using it. We use Google Meet inside the company. We're using Riverside to record this. They're not done. They will keep on evolving for various things, and so that means you have to keep on iterating. And at some point, if whether it's Google Meet or Riverside guys decide, okay, the core architecture of it doesn't allow it to evolve the way they want to evolve, they should, they can rejig the core, right? Redesign it, which kind of leads to that other thing that we talk about a lot internally, which is being dispassionately passionate, or strong ideas weakly held, which is strong opinions weakly held. So you have an opinion, you believe in it, you work hard at it, but if given information or data or knowledge that shows that this is not the right thing, you back off and you move on.
Yeah.
That kind of ability to break that mindset, requires obviously significant cultural adjustment in the company.
Yeah, I think so. It's basically like how you can have like open communication, like not depending on hierarchies, like how you can have a way of gathering this information and then let everybody to contribute, right? Then
Yeah.
people feel that this decision or the first principle thinking came as a collective effort. So then they can understand the why part of it as well as everybody is part of that particular decision as well.
Yeah, I think the a long time ago, I think Tyler wrote a blog about software engineering. Tyler was our CEO for a few years. He wrote a blog about a software company is really a creative company, right? I can't remember the exact title, but this blog is somewhere. It was a great blog, and it was about the fact that uh, people in a software company, whether it is a software company or software people in a business, right? In a non-software business, uh, they are problem solvers. Their purpose, the reason you study computer science is to learn how to solve problems for other people, not for yourself, right? So when you are a problem solver, you learn techniques for how to solve problem. Decomposition, algorithms, all these techniques that you learn about how to solve problems, and this stuff that we are talking about now. Um, then and those people, in order to be able to solve them in the best possible way, it's like creative work, right? You can't take an artist who's brilliantly creative and put a lot of constraints and tell them to create great art. And you can't actually tell artists to create great art. They create it when they want, when they can, when they feel like it, when they're passionate, when they're motivated, right? So same thing is true about great architecture in software. It doesn't come because somebody says, okay, here's, by tomorrow come up with a solution for this. That's again why iterative architecture is very, very important, because you might get a better idea in a week and you've already gone down the path. So okay, at some point you decide, okay, we'll do that for the next version, we'll let this one go, or you go back and change it, right? So that approach of creating that culture of open communication, the ability for anybody to challenge the way things are, etc., is really, really important, because otherwise you get into this mindset saying, look, we've done all this work over the years, you can't redo it, you can't do it again. And again, there are many. Elon has hundreds of examples, of not hundreds, but many large scale examples. NASA, if Elon went to NASA and said, I'm going to build a company that's going to send rockets, it's going to be much more efficient, 100 times more efficient, 1,000 times more efficient, they would have laughed him off, right? Saying, no way, you can't do it, it's too complicated, too hard. And instead, his approach is go to the first principles and say, why is space travel expensive? And he has articulated this very well a bunch of times about one problem is nothing gets reused. You throw everything away every single time, right? Imagine, every time you drive a car, you throw it away at the end of it. Then car travel will be very, very expensive, right? The fact that we can reuse it is what makes it cost effective. Same thing for a computer or a phone. I make one phone call and I throw it out. Right? That's basically the way it was working, and various other aspects of those things, right? So that kind of approach comes when people who are in one of our culture somewhere I can't remember, in architecture presentation for StubHub a long time ago, I had a slide saying, don't become old and jaded. Right? If a company or a leadership team or a technical team becomes old and jaded, which is, we've tried that didn't work, right? Then you'd never get an Elon like transformative thinking going, because old and jaded, right? We've tried to make the rocket better, it didn't work, so give it up, basically. So I actually remember a story in IBM. When I was in IBM, before starting WSO2, I presented something we were doing. It was called the Colombo Project, which is kind of a precursor to what WSO2 became, middleware platform. And one of the senior architects in WebSphere, after I presented at this WebSphere platform architecture board, came and said, so you think you can start from a JVM and rebuild everything we've done, and this mainframe WebSphere level quality stuff? I was like, it's hard.
Yeah.
Why not? Right? And the answer was, you have no idea what you're saying. And that's the best part. Don't have an idea what you're saying. Then just go off and do something wonderful.
Yeah. Yeah. And throughout this podcast, like we spoke about a number of things that we like introduced through first principle thinking, like cell architecture, business service platform, and platformless is another good example. So let's talk a little bit about, like, I think we can take platformless as an example, and then a little bit digging deep on how we came up with that concept, and then how we applied the first principle thinking.
Yeah, I think that's a very good one. So why do we end up creating the concept called platformless, and why do we end up creating Choreo, which is an incarnation of a platformless platform, right?
Yeah.
So the problem that we are interested in solving in WSO2 is basically making it easier to write applications, whatever kind of applications, enterprise business applications, technical components, APIs, integrations, workflows, whatever, right? But then the reality today is two realities I'll mention. First is, pretty much nobody knows how to build software on time, within budget, and at the quality that you desire at the point of starting that idea, saying, I need a piece of software for this, right? Every system gets hacked. Every system is late. Every system ends up costing more. So then you have to ask why. How do you solve that problem? So that's one metric. The other one is, I think, I can't remember the exact ratio. For every dollar spent on buying software, businesses spend $7 on building things on top of the software. Right? So you buy this technology saying this is a tool for workflows, this is a tool for API management, this is a tool for identity management, whatever it is. But then to do actually what the company wants to do, they need to spend $7 more, 7 times the amount of dollars on services. That's why the service business is so large. But then again, so the total cost is 8, and the service, the 7, ends up being a mess. You have to do more. Whereas the product often is not the usual problem, because product is very focused. It does what it wants. Especially if you buy WSO2 stuff, it'll work very well. Yeah. If you go back and ask, okay, how do you solve the problem of actually delivering software on time, within budget, at the right quality? Then you have to ask, okay, why is it not happening? What are the reasons? So obviously there are many reasons. One is maybe you don't have the right kind of people. They are not skilled enough. Maybe you're not using the right tools, and so on, right? There's a ton of things. But it's a comprehensive problem. That is, it starts from the point of designing or specifying or thinking about what problem you want to solve, all the way to getting the result into the hands of the fingertips of the user, right? Every part of it needs to be dealt with. You can't solve this problem by saying, well, I've got a really, really good CI/CD system, or I've got Kubernetes, now that problem is solved. But great, we have solved each of the problems to a great extent. But what we see is every customer, every company is putting together a story for how you manufacture software from an idea to delivery. Every customer is figuring that out. Whereas every customer needs to build software. I mean, this every company is software company mantra. We don't need to talk about that. That's well accepted now. So, but why is everybody trying to figure it out? We all need electricity, but we don't all figure out how to make electricity, right? We just plug in and it works. It's platformless. I don't know how the electricity comes to my house, right? There's all kinds of wires, there's transformers, there's generators, there's solar, hydro, whatever, right? I don't care. Something happens, power works, right? And I get upset when the power doesn't work. That's platformless thinking about power. I just plug in and I use it. So the process of software engineering, of taking an idea and seeing it through to the end, is what we realize is really what you have to improve end to end, not just a piece of it. If you want to really attempt to solve the problem, okay, how do you make it possible to build software on time, within budget, at the quality that you desire, right? And all three parameters being optimized. Typically, you might get two, but not one. Throw one out to get the other two. So to get that done, you need to think through the whole process and need to create an environment that says, okay, now that is not something you should think about, because your problem, you should think about the problem and the solution, first principles thinking, orthogonal decomposition, reuse, all these things that we've talked about, and we're going to keep talking about how to do architecture, putting all that together, and then just saying work at that level, but everything underneath, I don't see. It's just there. That's platformless then. The platform on which you stand is invisible, right? It's like when we are doing this recording, we are using various technology, but we are not focused on that. We are focused on the conversation that we're having. If we have to focus on that, whether the recording is working, the network is working, all these problems, then you can't have the conversation. Your energy goes to the wrong place. Right? That's what platformless, that's how we came to it. Again, that comes from thinking deeply, referring to the things we talked about earlier, thinking deeply, being clear about the problem, understanding why you're doing it, who you're doing it for, and then iterating.
Yeah. And our learnings, right? Like helping organizations to build a platform for 18 plus years, that kind of helped us. And then we identified an immediate problem, like people who's building platforms, they are not building it, right? And then again, people who's trying to build it, they are kind of in this vicious cycle of building platforms over and over by spending money, time, but not delivering value for the business, basically.
I mean, I think again it comes down to that entrepreneurial definition, which is, look, if you don't feel the problem, if you don't know the problem, you can't solve the problem. That's why you can't lie down on the ground and look at the scene and ideate and figure out a company to start. It doesn't work. It comes from understanding a problem. So we understand this problem because, as you said, for 18 plus years, we have been helping customers, and we have I think about 200 companies we have helped build platforms using our technology, right? Not as a services thing, but we've been the ones consulting on how do you set up a multi-environment architecture, how do you do governance, how do you do all these things that you need to put together, API integration, API management, all these things that you have to put together, we have helped. So we've learned from repeatedly doing it. Look, these people are doing the same damn thing over and over again and getting it wrong on top of that and spending millions of dollars doing it. And now if you just come to Korea, you get it free literally within a minute. Just sign up and there is a platform. You can come as a platform engineer. You can come and attach your Kubernetes clusters, set up all the stuff that you want. But it's literally no time.
Yeah. So I think now the architects who's listening to our podcast mostly, like, they might be thinking why this is important for me. So I think like we identify the role of architects, right? Like it's kind of very critical in the organization. Like there are many definitions for architects. I think Gregor Hobbs explained it as the person who riding the elevator up and down in the organization. And I always think architects are like knights who kind of critical decision makers of this entire software development process. I think that's why the first principle thinking is pretty important for the architects, because the decisions that they are taking affecting the organization as well as success of the products that they are building.
Yeah, so I'll give an analogy from the word architect. The name architect comes from construction, right? It's architecture as a as a discipline is for construction or design and so on. When my parents built the house that I grew up in Arhampita, uh, uh, my father had worked in Oman, and we were not. My father was a military officer before that, and mother was a school teacher. So it was the money from there that was building this house, and they didn't have enough money to hire an architect, right? Because an architect I think the rate is like somewhere between 10 to 15% of the total cost you have to pay them, and they cover end to end, right? Architecture engagement with the project is not just like here's a structural diagram, here are the things, and I'm done. But they engage right throughout until the thing is handed over, right? So until it's completely done and occupied, the architect is engaged. So we didn't hire an architect. We had a contractor who said, no problem, I know how to dig the holes in the ground. This is in a marshy land in Nanaiput, right? It was part of Colombo, on the edge of Colombo. Uh, and so, when you don't have enough money to do various things, so you cut corners. And so we cut a bunch of corners on how the beams were tied together and so forth. And one of the 12 beams, piles, not piles, they've actually just dug into the ground, and a concrete beam, concrete pillar, slipped underground, under the ground, and the entire house tilted. Right? And we growing up, the house was always at an angle, and then over time we tried to fix it in various ways. Upstairs we had like a step function inside, so you go from room to room, you go down, and the other way you're going up. But that's because there was no architecture support to go from beginning to end as an architecture. So I think the point is, architecture in a software world doesn't stop when you have a design. Right? Often people get that wrong. Architecture goes all the way down to making sure it solves the problem that you're trying to solve. And a great building architect works with a customer to understand why are you building this building? What is the purpose? So when we did the Avinya school, right? We had a great architect, Dan Amarasena and team from Design One, right? Those guys, they were involved from the conceptualization of what is the experience we're trying to deliver from the school. And we started off with a contest to select the architects. I wrote up a brief saying this is the vision we have. Then once we selected one, we worked much more in detail. Then this is the experience we want the students to have. And then you start with that. Then you have a high level conceptual architecture. Then you have the next level of detail. Then you start building. Then you make changes as you go along. Now, obviously, the building iterative architecture of the foundation is a little bit difficult, right? I mean, you can do it, but it's very expensive. So you try not to do that. So you build a foundation that gives you all the variability that you want to have, right? And a lot of modern construction is where the buildings are just shells. They're just structural shells, and you do whatever you want inside, basically. Right? So these kind of these kind of principles about how as an architect, as an architecture professional, you need to think about, not like I'm just there at the beginning, I draw PowerPoint and I'm done. So if you can't go all the way down to the code, a good building architect can go down to looking at bricklaying and say this is not correct, or this is how it should be laid, right? I mean, if you think about it, actually, to this date, when I go into like a very large building, and you look around and see all the detail that went into thinking to make this work, every light placement has been thought through by somebody, right? And the infinite amount of detail. Look at an amazing terminal like the new LaGuardia terminals in New York, right? They're beautiful. The level of detail that you think about, and to get it done from structure all the way down to actually finishing the job, selecting colors, selecting light, shadows, all these things, that's the level that we need to get to in software. And of course, to be fair, civil engineering has been there for what, 10,000, 20,000 years. We've been building things.
Yeah.
Software has been there for less than 100 years, this kind of software, right? 75 years at best. So we have a long way to go, which is fine. We are very, very infant technology in terms of knowing how to solve problems using this digital infrastructure. So, and just like in construction, we are still evolving. We will, of course, evolve and figure out new things as time goes along.
Yeah. I think that's a great advice to architects. Like fundamentally, it's about understanding the why as well as understand the end user real requirements, and then applying the first principle thinking. And you highlighted some skills that architects should have, not like just PowerPoint architects, how you get into the actual work. I think that is something we can discuss in another episode as well. That might be really helpful for the architects. And I think it's a great conversation. And like, I think we put the foundation to first principle thinking. And I think the viewers can look at and find more information about. Our idea is to give you some context and then you can dig in deep. So yeah, thanks for joining, and we'll connect with you in another episode.
Yeah, thank you very much. It was a fun conversation, Sanka, as always. And yeah, I think you said it right. Architects need to think about themselves as a, as a change agent, as a person who is always open to new ideas, as somebody who's just a creative. And and if you don't want to do those things, then think and see whether that's what you're going to be successful in, right? Life is short. You only have one run at it. Steve Jobs had this line saying, "You spend 80% of your wake time in this place called work. You don't like what you're doing. Why are you doing it?"
Yeah,
Thank
I
you.
think that's a great quote to end the episode. Thank you very much.